Welcome. This is the first episode of the Into the Weeds podcast. I'm Tony Kelbert. Over the course of my career, I've worked on teams building everything from private jets to industrial composters. But then 3 years ago, I realized that I can do this stuff, but it's not really what gets me out of bed in the morning. And I needed a creative outlet and a way to talk to people. So I started writing on LinkedIn. And people liked it, or they seemed to, and they started engaging. And so I started building a community there in startups, in hardware. And what it's resulted in is some great opportunities like this one, the opportunity to talk with Nabeel Allana, the CEO at Dystr. Nabeel, I'd be really curious to hear a little bit about your background and what you're building at Dystr.
Great to be here, Tony. Thanks for having me. For a quick background, I've been programming since I was about 7 years old. Programming became kind of a Lego set for me growing up. Started learning about AI, ML starting in about 2012. And I've been fascinated in the field ever since. I later joined a few hardware teams, including a product design team at Apple, contributing to many of their products, such as the MacBook and the Apple TV line. In my last 2 years at Apple, I was a technical lead on several of the subsystems within their autonomous vehicle project. And in my time in hardware teams, I noticed there was a stark discrepancy between what tools that hardware teams needed to build things using software versus the things that software engineers needed. Usually the software tools were vastly overkill and not quite right for what the hardware teams really needed to do with software. So what we've been doing over at Dystr is really building a great environment for teams that don't code for a living to program computers to do things for them, such as writing and running analysis in the cloud or automating workflows without having to learn or become software engineers effectively, but giving them the same utility.
And that's something I've really appreciated about using Dystr is my software background is negligible, but I'm able to just tell the system what I want it to do, and it generates the code to do it without having me sitting there for hours and hours trying to figure it out. So I've more questions for you just around how AI works and the basics of it and security and things like that.
That's great. Looking forward to it.
I think there's a lot of anxiety in the marketplace about AI tools, and everybody's like, oh my gosh, AI is going to steal my data. I'm not going to type this great business idea I have into ChatGPT because then it goes into the context and people can pull that out. And, it's essentially storing all of the autocomplete data from Google and it's accessible. But I mean, is that true? Is that anxiety justified, or how do these actually work?
I think the short answer is it depends on the product, which is kind of unfortunate because there's a big variety in the marketplace right now. If you look at the free version of these free products, many of them are monetizing this way, right? In which they are monetizing by going and taking your information as training data, because that's how they justify giving it to you for free. Many of these other products are not. So I think there's a big variety out in the market. Now, fundamentally, these language models themselves, they at inference time are not, they're not absorbing into their model. So that's going to happen separately. Someone can sit there and collect all of these chat records and all this stuff and then use them for subsequent training, but it's not happening at inference time.
That's when I type something in natural language and it infers what I mean by that before it runs out and does the calculation.
Yeah, that's right. You can kind of think of what's happening at inference time as effectively being a crap ton of linear algebra. You're taking effectively a sequential series of matrix multiplications, accumulations, etc. And at that point in time, it's just math, and it's just running in a GPU. All that language models are effectively doing when they run is they load all of those values for each of those matrices into graphics RAM, and then it is multiplying successively through based on the topology of the model itself. Really, you're just temporarily holding it in a graphics RAM.
Yeah, that was the key point I wanted to zero in on. That is just in RAM. It's not actually going into long-term storage.
Yeah, so then the long-term storage happens on the application side. So then it's up to kind of, who is storing it and where. If you are, example, Instagram, then you are storing the stuff on Instagram servers and you're using it the way that Instagram uses that data. If you are Microsoft OneDrive, you are storing it in a completely different way with different protections meant for a different audience. And I think that analogy is kind of similar in here.
So that's interesting, because a lot of the anxiety is like, oh my gosh, it's going the Instagram way, throwing everything in a bucket, and then it just has access to everything in the bucket. How does Dystr handle it?
Yeah, so we store the information on AWS servers that are encrypted at rest, encrypted in transit, etc., and we have strong data partitions between customers on our system. And we do not cross-pollinate. We do not use customer data for other customers. It's very siloed. And we also offer a way to deploy the product in which it's on a completely separate set of machines that it just belong to that customer. So we allow kind of an enterprise deployment model that isn't a consumer style system like what ChatGPT and some of these other kind of public systems are.
You think there's a realistic path toward ITAR certification at some point then?
Oh, absolutely. I think you can probably do that right now. I mean, at the end of the day, these things are just running compute, right? Like at the end of the day, there's a hard drive somewhere that is saving the persistent stuff, and then there is a piece of RAM that is saving the temporary stuff, and then there's registers at the chip level that are doing that are storing the very temporary stuff. So at the end of the day, it's all the same thing as regular computers. There's nothing too much more complicated other than the fact that there's just a lot of multiplication steps and math steps that are happening.
So this is going to get really into the weeds. Language and math, like separate in my head. So how do you turn language into math through this matrix multiplication? Like individual letters, or is it what each word signifies that's embedded in a matrix, or what does that actually look like?
You can do individual letters if you want. 0 represents A, 26 represents Z, or 25. I need to double check that one, but you get the picture where each entry is a character, right? And that's a crude way to do it. But what you end up finding is you can reduce the number of inputs by not just doing A to Z and 0 to 10, etc. You can make it that turns out like the word "and" shows up a lot, and you can make that an entire character, right? And if you do that with the most common things, and if you expand it from 30, 40 input options to, let's say, 1,000 of them, and you select the 1,000 most common kind of sequences that come up, they really compress the text nicely right at the beginning. So that's usually what they do, and that's what they call a token. Is like the word "and" is a token, right? Like the word "the" is a token, and not because you can do it with THE as 3 separate tokens. You can train models that way too.
Do you ever hear the story about how the Chinese keyboard was developed? Chinese is pictograms, like tons and tons of pictograms, and how do you put 80 bajillion pictograms on a keyboard? You can't. And so they kind of did the same thing where they had all of the pictograms, and then they took what was common about certain ones and just started condensing it down until they had a manageable number of tokens that you could enter on a keyboard. And the weird thing is nobody uses a Chinese keyboard the same way, because you're painting your words in a way, which is bizarre, honestly. But it sounds kind of like what these AI models are doing. It's tokenizing things. And so you end up with essentially computerized pictograms with the numerical equivalents, so that it can do math. That's fascinating.
Yeah. So then they all kind of just turn into vectors.
So a sentence might be just a vector with a certain number of, oh my goodness, it's been a long time since I've done vector math, but a certain number of components that tells you exactly what the meaning of that vector is.
Exactly. It's just a sequence of numbers at that point, and that you effectively encoded that sentence into a vector.
Okay, so now you've got this vector, and you're going out into this ginormous training database to say, okay, now tell me what this vector means.
Think of the training of these models is split into 2 main pieces. The first is what they call pre-training, and the other is post-training, even though they're both training. So I don't know why they call it post-training, but anyways, long history there. So in the pre-training phase, effectively what they're doing is they're reading a ton of text with the goal of trying to predict what comes next. And they do this with effectively the whole corpus of the internet. And something really interesting starts to happen when you use these transformers in this kind of way in which they start to develop a really rich understanding of what the text is representing and what the world that it's representing is. So they develop a pretty decent understanding of concepts that you and I know of like what is gravity? I mean, to the extent that it can be extrapolated from a mass of text. Now, there's kind of a big asterisk there, right? Of like, if you went and did the same kind of exercise with a massive text from the 1800s, you'd end up with a very different understanding of what is that concept than if you did with now. But that's a different question, right? And then they end up with this effectively this system which is able to effectively guess what comes probabilistically next after a sequence that you put in as an input.
So you take your input, your query, your input vector, you send it out into this world of data and matrix multiplication and things like that. Like, what does it do with that input when it gets into this big world of structured data?
Yeah, so I mean, so on the pre-training phase, you've got this model that is effectively developing an understanding of concepts and whatnot in the world to the extent at which it can, with the goal of predicting what comes next in a sequence of text. And then imagine if you, so let's skip the post-training for now. Let's just imagine if you went and told it, what I want you to do is predict what comes next in the transcript of a conversation. And that's effectively what it's doing in chat. Is it's saying, all right, like you are like there's a backdrop of like, all right, you are this bot, you are in this product called Dystr, you are et cetera, and you are in the middle of a conversation with an engineer. The engineer says, blah. What do you say? Oh, here's what comes next, and then it's finishing that. Right, it's finishing that transcript. So effectively, an end token, right? Then stops, and then it's back to you, and then back to this.
So working with an AI tool is going to be inherently iterative. You're going to say something, it's going to finish it. You're going to say, not quite, let's try again. You're part of the equation in the chat window.
You are. I don't know if it's always going to need to be that you always need to be in the loop. Maybe let's actually finish the understanding of like what they are, because then I think like the rest of this will make more sense. So at the beginning stages, right, you're just feeding it tons of information and having it effectively learn how these things are related to each other to develop kind of an understanding, the world model, if you will, within itself. Let's take a question like there's a fun article a friend of mine wrote that actually encapsulates this really well. So I'm gonna borrow one of his examples. Is Aragorn the king of Gondor? Now, if you go off of just learning what's in text, how do you know what is true? Is Aragorn the king of Gondor? Like, it's like, if you think about it, if someone has only ever read information in books and text and has never lived and doesn't know what is true and what is not true in a sense, which is a completely separate philosophical question, then how do you know if Aragorn is the king of Gondor or not? So that's effectively what these things, in a sense, kind of like struggle with, because they do not have the concept of objective truth, if there is such a thing. They are just going off of learned things.
So whatever it has been told has equal validity. It's not weighed against some measure of truth. It's, if I was told this, then I know that might come next in the conversation. Aragorn is king of Gondor. What does that mean? I don't know. But according to what I read, that's accurate.
Yeah, and like then to really answer that question, you need to know kind of, what world are we even in, right? Like, I mean, Aragorn is the king of Gondor in the Lord of the Rings world. But if you look at it in the Batman universe, like, not at all. What universe you're currently in and what is the current backdrop to what the conversation that you're having is matters. And that's kind of the goal of the post-training phase. So that's the second phase in which what you're trying to do is, because once you're done the pre-training, all of these possible truths can be true at the same time, as far as the model is kind of thinking. In a sense, it's all superimposed. All of these different even like across our world, there's just so many different ways to interpret what is gravity. Is gravity, what is it, right? Like that's, if you ask someone that is hyper religious, you're going to get a very different answer than if you ask someone that is hyper scientific. So the objective truth of what is gravity, especially as understood through human text, right, is not super well defined. And what you're doing in the post-training phase is you're trying to effectively collapse that probability distribution, so to speak, and you're trying to bias it towards certain ways of a certain backdrop of the universe, so to speak. Really, that's what post-training is.
So pre-training is saying, let's just grab all of the stuff. And post-training is saying, okay, let's filter that a little bit and let's apply some probability math.
Yeah, like let's take the same example of like, is Aragorn the king of Gondor, right? After pre-training, the model would think that, that's almost as likely true as is Vladimir Putin, the president of Russia. Like, it's like, it's like, all right, I've read a lot about both. I've seen both in both contexts, so I can see how that would be true. Now, what you're trying to do in post-training is you're trying to reduce the probabilities of some things, right? Like, for example, you may want to, let's take a math example of like, create me a Bodhi plot of XYZ. And it's like, I want the code for it. If it's been fed thousands of ways to do this, some with mistakes, some without mistakes, then it needs to be able to go and decipher which one of those it should bias towards. And what you're doing is you're effectively biasing it towards some things and away from other things. And that's really what post-training is. You're almost kind of forcing it into a narrative of itself.
Nabeel, it's been great chatting with you. I'm really excited to see how Dystr evolves and where AI will take the next generation of engineering teams.
Likewise, thank you so much for having me.